Hello everyone, I'm Ishika Poddar. Having already learned about the concept of Inorder, Preorder and Postorder traversal, today let's discuss the implementation of these three traversals. So starting off with Inorder traversal. What was Inorder traversal? Inorder traversal was basically L, N, R means left, then node and then right. Okay, so what will happen? First, we have this function in order which takes root and the result vector. Result vector is basically storing the in order traversal. Okay, so what is the first step? We check if the root exists, means if this is not null. If this is null, then we'll return. So basically this will check if the root exists. If the root exists, we are calling it for the left. Means it will call this for initially the pointer was here and then the pointer moved here and then again this recursion will call again on roots left, so my pointer will move here. Okay, it comes here again, it will call, so it would go here, but next when it comes it will check if the root exists, if there is anything here. No, it's null, so basically this won't execute, and from here it would return. Upon returning, what will be the second step? Its roots val, it will push back in the res. So what does my res contain now? My res would contain now 4. Okay, next it returned here. Now it will call on roots right. So is there anything to the right? It's null, so again it would return, and it would return from here. Now this left part of this 2 has been traversed, so it will come to the second step, that is res dot pushback roots val. So now my vector will again have 4 comma 2, and then it would call this on right, 2's right it would call, and yes, 2's right it would call. Now for this, when it comes here, does it has anything to the left? No, so it would return, and it will push back the value that is 5. It will push back the value that is 5. It will again do the right operation. Is there anything to the right? No, so it would return like here. Having already traversed this 2, it returns here. Now we have traversed the full part, left part of this one. So res dot pushback roots val means now I can enter 1 to my res vector. Now it will call on one's right. It will make a call on one's right. Comes here. It comes to 3. Now there will be a call from this 3's left. There will be a call on 3's left. Is there anything to this 3's left? No. So it would return here. It will now execute the second step, that is res dot pushback roots val. So now res has 3. Again it will make a call on the right, the third step. So it will make a call on the right. Okay, and then it will check, is there any roots left? No, it would return. It will push back its value, that is 6. Okay, is there anything to the right? No, So again, it would finally return. Is right? No. So it will return, and finally, this will be our resultant vector. Okay. So that much for was for the in-order traversal. Let's move on to the pre-order traversal. Pre-order traversal in a similar way was N L R. Means will traverse the node first and then calls for it left and right. So basically, this one we push back first into the rest vector. Rest vector push back one first. Now we call for its left, means comes here, and then again this pre-order is being called. First statement executed is to be roots val, we need to push back. So it will push back to, again it would call on the left. So from here again we call on the left. It comes, it goes here, comes here. Again answer at pushback roots val, means now 4 will come here. 4 will be pushed back. Okay. So again it would call for the left. Again it would call for the left here. But there is nothing. So it would return. And it would call for this right. Is there anything to the right? No. So it would return. So basically it returns now. Now as we have come here, this 2 left has been completed. So here it would make a call on the right. 5 will come. Now 5 will be pushed into the vector. Is there anything to this left and right? No. So it would return now. It would return now. It's already been done. It would return from here now. We have traversed the left part and this node 1. So the right will be called now. So there will be call on the right part of this, that is 3. We come here again. Answer at pushback roots val, means now 3 will come in my rest vector. It would make, and then it would make a call on the left. It would do this again. Answer at pushback roots val, means left was actually 3's left doesn't exist. So this condition would fail and it would return from here. It came here now. The third statement will execute, that is roots right. So it will make a call on the roots right. It comes here, answer at pushback roots val executes. So 6 will be pushed back now. 6 will be pushed back now. Is there anything to the, so it would return from here. Is there anything to the left? No. It would check this condition and it would return. So is there anything to the right? No. So it would return. It has already been traversed. So now that will be our final rest vector for the reorder traversal. Okay. So now the last one, that is the post order traversal. Postorder traversal was L R N. So having this node here, we call on the right first. This first statement executes, that is calls on the right. Again comes here, checks if roots is null, no. Again makes a call on the right. Again it comes here, is the root null, no. Again makes a call on the right. Okay, so now this root is null. So basically it returns from here to this. Second statement executes. That is, it calls on the right. Is there anything to the right of this? It calls on the right, and then again it comes here. It checks if there is root is null. Yes, the root is null, so it will return again back here. And then the third statement, that is answer or pushback roots val, will execute. So my rest vector will now contain 4. My rest vector would now contain 4. Okay, so it's executed. Now it comes back, returns to 2. It returns to 2. This left has been already done. So the next statement is post order roots right. So it will call on roots right, means this will execute now. It comes here and then checks if root is null. No, it's not null. So it will call on roots left. It would return from here because this is null. Comes here. It will again call on the right. It will return. And the final one will be executed, that is answer or pushback roots val. So basically now my rest would become 4, 5. So again it will return back to this. For this node, the left and the right part has been executed. So the last one, that is roots val, we can push back now. So 2 will come. Okay. Now 2 comes here. From this 2, again we return to 1. Everything traversed. Now for this 1, this left has been totally traversed. We go to the second statement, that is roots right. So it makes a call on the right part, that is 3. This 3 comes, checks whether root is null, no. Makes a call on the left. Does left exist? No. So again it will make a call here. Doesn't exist, so it returns here. And then it will make a call on the right. And then it will make a call on the right. So it would check again if the root is null. No, it's not null now because it's 6. So this first statement, that is roots left, it will make a call from 6 to roots left. Now when it will again come back here, it would check the root is null. So it would return from here. And the second statement will be executed. It just makes a call on the roots right. Again it would tell that the root is null, so it would return. And the third statement will be finally executed, that is 6 vector dot pushback 6. So basically now 6 will come to my vector. And having done with the right part, it would return here. Now answer or pushback roots val will take place. So we have now 3 here. And having done this, having traversed this 3 totally, it would return now to 1. And this final statement will be executed, that is, will have 1 in our post order. So this would be our final post order traversal for this tree. Okay, so this much was for the code implementation of the tree traversals. Thank you so much.